Warning: you may see some unsafe practices and safety precautions being ignored. Make sure you always read and understand all safety guidelines that came with your tools. In other words, do not try this at home.
Welcome back, everybody. I am Terrence King, also known as King Rawl on Thingiverse and King Rawl 3D on Twitter. This YouTube channel is far from finished, and that is exactly what I am on this project, is far from finished. Today we're moving on to the Z-axis. We've already assembled the extruder and the X-axis. The next step is the Z-axis and 3D printing and assembly. So let's go ahead and go through what my process of creating the Z-axis for this. This is a normal vertex group for the RepRapPro Mono Mendel or Tricolor Mendel. Pretty much this is the Prusa Mendel version 1. This vertex group right here, the feet and this section up here, I pretty much did away with all of this, so let's just go ahead and delete those. Now we're stuck with the Z motor mounts. Whenever you're building this, you have two sets of this, one on either side of the machine, and this right here is the main component which I modeled everything for the Z-axis on. So let's just go ahead and tab into edit mode and we'll take a look at what we have here. These are all the vertices. Each individual one of these are the vertices, and instead of making measurements and everything, I like to throw everything in a 3D universe here in Blender and get a feel for how it's going to look, not quite the measurements on how I want it to look. I don't know if that makes sense, but hopefully it will after I'm done. But so this hollowed out section right here, we already know fits the NEMA 17 motors. I'm going to be using the NEMA 17 motors again in the Rapaché project. So I'm not going to mess with that geometry. I'm actually the way that these are going to be mounted is that this is going to be, the motors are going to be on the bottom rather than the top. And the reason for that is because the well, first off, this project is modeled after Benjamin Heckendorn's Briefcase 3D printer or portable 3D printer, and his was on the bottom, but that makes good sense. One, because you don't want hardly any weight or a lot of weight at all on top of the machine. You might vibrate, especially being in the center of the machine, and any swaying motion that happens, you might get some Z wobble. The NEMA 17 motors, the height of it is good to match the height of the bed itself, the Y carriage, and then the extra bit on top of the Y carriage, the length of the bolts that go up to the actual bed itself. So all that will be taken up by the Z-axis motors. So let's go ahead and show you exactly what process I went through on how to make my Z-axis motor mounts. So early on with this, I knew that I wanted to fit inside the frame, and I wanted it to be as thin as possible. And as I was putting everything together, I found that in the Prusa Mendel, the reason why it has two bolt holes, one on either side, and that's for frame stability. And since all of these pieces up top connect to each other through a rod on either side, the way I'm building this, they're not going to be connected. So each one of these is going to be an independent corner of the box. And since that's how I'm going to make it, I found that I didn't need this side over here. I still needed one at least for the bar clamp right here. And for the top frame corners, I also needed one, that way the bar can go all the way across, and that's actually going to be the only one single bar that I'm going to be using for frame stability, and that's just to go across the entire machine. That actually, I've recently been thinking about changing the design just a little bit, and that bar is actually going to help assist with the top of the box holding weight for whenever you carry it, because the wood that I'm going to be building this out of, the box, I believe it's got a very likely that it's going to start warping because the carrying handle is going to be in the center of it, and if that's going to be the case, then I want a little bit more support, so that one bar going across is ought to help really well with the keeping everything straight and aligned. But let's go ahead and go on to how I went ahead and changed this. So as I lined everything up, I found out that I didn't need this side over here. So my modeling methods, I just went ahead and deleted all those faces, and honestly I deleted most of these vertices. So, but because I needed this side of the motor to have a wall sitting over here, let's go ahead and build that wall up. So move this over just a little bit. Face. Okay, so that's basically all that I had to do was delete that hole, delete that hole, and move everything over, and just have a wall right there. Okay, so that created the section that I was needing. Now I found that I wasn't exactly happy with this just sitting on top of the motor, and I needed something going down the wall of the box all the way down to the bottom. That way I have something a little more substantial to hold to. Otherwise this is just floating up in the middle of the box. Not exactly in the middle, but higher up than that, actually on the bottom. So I wanted this thing to be able to mount to the bottom and the side. So I actually had measured out length of the height of the NEMA 17 motors that I'll be using, and I just moved everything down. Whenever you move everything, especially around a hole like that, then you're gonna be moving edges over the front of faces. So I cleaned everything up on my original models a lot better than the way that they come out. But an easy way to do that is just extrude it. After everything's selected, just extrude it, and then it creates all new faces. But I moved that down to the size of the NEMA 17 motors. So this is the basic shape of what I was going after. I figured I can go ahead and save on plastic since I didn't need this little lip down here. Just take that and move it over. And of course, like I was saying, I cleaned everything up a lot better than this. But you got the hole right there. It pinches the Z-axis smooth rods just fine. And actually this right here is going to keep the entire frame perpendicular to itself. So these motors will be sitting flat, and then those smooth rods will be pointing straight up. And the extra length that this goes keeps that from twisting and breaking most of this plastic right here. And well, I needed the top where the idle bearings are going to be to pretty much match, not necessarily the exact shape of this, but the functionality of this. So I didn't need one side of this, and all this was at an angle like that. So one side's holding this. The bearing's going to be sitting in here. That's remodeled a little bit different. This is essentially what I was going for, was just a like a wall bracket angle going down, and then a flat top and a flat back. So this is just garbage actually. But let's go ahead and show you what it is that I finally modeled. The final version of the Z-axis. Alright, so of course everything's all smoothed and nice and pretty like, but this is essentially the same thing which I just showed you for the NEMA 17 motor mounts. So the top vertex has the one side over here flat, that's going to be sitting flush with this side of the box, and the x-axis rides inside this wall right here, so that motor couldn't be sticking out over here, so that's why I had to move this one over. I said that in the previous video, but you can get a better look at what I was talking about in this picture right here. Now the Z end stop, I didn't have to modify that in any. I was actually wanting to mount it to the bottom right here, but because this is taking up slack right here, this is where the hose is going to be clamped on in between the motor and the Z-axis lead screws. So that's preventing the x-axis from going down any further than that. So I needed the Z-axis end stop to be a little bit higher than mounting it down here. And I didn't show this on the model, but since this is the motor mounts down here are only going to be clamping the bar one on either side and not having that all thread going all the way across. So this can be either a bolt or just a trimmed down piece of all thread. But when you tab into here, this is actually a recess for a nut or a bolt head. And easy way to install that is actually just heat it up with the soldering pen. That seems to be a pretty popular method within the 3D printing community of insetting things such as bolts and screws and standoffs. This right here is going to be the edge of the box, and that'll be covered. So after that gets installed, that's not going to be moved, and the only thing that you have to tighten or loosen would be this one right here, the nut that goes on this side. But back up here to the top, since I'm still using the M5 all thread, the Z-axis lead screw, I'm also using the 608 bearings, which the inner diameter of the bearing is actually bigger than the 5 millimeters, so I needed to make a bushing to help fill in that area. And this is basically just a top hat shape. You got one cylinder and a larger cylinder with the 5 millimeter cylinder hollowed out, and I tap the inside of this with a 5 millimeter tap, and that helps the all thread screw in nicely and get everything nice and flush in there. Alternatively, you can use a bigger drill bit and just push it on or glue it on, but that's the way I chose to do it. And now looking at this corner piece right here, you still have the one bolt up here in this section, the angle part of the bracket coming down here, and then the flat side over here for the box. Now I found that the angle right here is actually very useful, considering that the x-axis motor is turned 45 degrees. So as I move that up, I still have all that clearance right there. And of course everything's measured for the 200 millimeters of height that I'm going to be 3D printing. So from from this lowest point right here all the way up to where that motor stops up here, it should give me at least 200 millimeters of printing space. And to make sure that I had plenty of room in the box, I needed to be able to mount my electronics in there. And this is just the case that this is the basic case for the Sanguino Lolu boards that I'm going to be using. I might not use this exact one. I might not even use a box at all. I might just mount it to the briefcase side, the wall of the box. That board fits just fine right where it's at. Alright, so on to 3D printing and assembly, and then onto the box. Thank you for watching. Boy, time lapses sure are fun. Thanks for sticking around. I have everything 3D printed and everything's laid out on my desk to assemble. Let's start out with what I started out with was the extruder. We're just set that aside for now. The X carriage that is already assembled. If you haven't seen that video, go ahead and check it out. I went ahead and installed the lead screw nuts and springs in these. If you look right there, that's a M5 nut. And the 3D printed Z-axis. So it's got the motors and the idler bearings for the top. Now you can take either bolts or the nuts and inset them using a soldering iron. That seems to be the popular method right now for doing things. These pieces were printed in PLA. I'm not usually a PLA user, but I had a roll of it, and just insetting these was very easy using the hot iron method. Okay, now to go ahead and install the stepper motors for the Z-axis. Now this particular part can be adjusted just because not everybody's stepper motors are the same height. Now if I used a smaller stepper motor that my original RepRapPro Mendel came with, those stepper motors are quite a bit lower, and actually that would help me drop the X-axis down lower towards the bed. That way they wouldn't be running into the tubing that I'm going to be using on the lead screws. Now there's a fundamental flaw in this design right now. The cable is coming out the end that the box door is going to be pushing up against. So it would probably be more ideal if I had it coming out sideways, so I can cut a notch on one of the sides for the cables to be coming out. Of course, it'd have to be the side with the that the smooth rod is attached to, that clamp is attached to on that side right there. Now, like I was saying, you can either use a cut-off piece of all thread, just the 8mm threaded rod, M8 or 5/16, whatever size that you plan on to be using for this 3D printer. But since I'm not using the bolts, I'm using the threaded rod. Just feed those in there into that first nut that you inset into that side over there, and this helps create your own bolt. That way your tensioning nut on this side that I'm screwing in can clamp against that smooth rod. Now everything is all the threads are clean and everything on this. I had to use pliers on this because I think the nut that I inset was just a little bit crooked whenever I inset that. So it's probably be best that you do that while everything's still warm and melty. But this 8mm smooth rod gets pushed all the way down to the bottom, and it bottoms out at the correct length. And the same thing goes for the idler bearing braces on the corners. Now these M5 all thread rods, I've already installed the tubing on them, and they just push down directly on the stepper motors. Now I'm going to be reusing the tube clamps for this from the RepRapPro Ltd files. So, and these have enough of a gap that I can install them at any time. Right now it's creating enough pressure on the all thread and the stepper motor that they won't be slipping anytime soon. So I'll install the other pieces later for that. So now both of the Z-axis stepper motors, the smooth rods, and the all threaded rods are all put together and installed. Make sure that you tighten down your clamp nuts. They only need to be tightened down enough to hold it from moving. Next comes your X carriage. Go ahead and install it. So you can't see it from this angle, but the smooth rod gets pushed into those IGUS bushings, and you go ahead and turn both of the lead screws at the same time. That way it doesn't get in a bind. Now as you're tightening this down, you got to make sure that the smooth rods is going up straight through the bushings and they're aligned. So I'm going slow, that way I can tilt it and align it where it needs to go. Alright, we're through. Now we just got to thread it all the way down far enough so that we can get those two top corner idler bearing pieces in. Now go ahead and take your 608 bearings, and these can be inset either they were a little bit of a tight fit, so I used my Dremel. If you have a good soldering iron, you might be able to heat those up and press those in the same way that the bearings were pressed in. Now we have to fit our all threaded rod across this. This is actually going to be helping with support. Whenever I first put this together, I used the short pieces just like on the motor ends, but I decided that for carrying this Briefcase 3D printer, it's going to need a little more support on that top part of the box. So I'm going to 3D print some brackets that actually attach to this all thread and attach to the what would be the top of the box, or the handle side of the box anyways. So of course, just like in the assembly fashion, you have a nut on the outside, your 3D printed part, a nut, and then on the other side it's nut, 3D printed part, and nut. Now the nuts are already inset in there, so all I have to do is just turn this to tighten it down until the end of the threaded rod is flush. And once again, I think this side was inset just a little bit at an angle, which is making it hard to thread on there, so I have to hold it with the pliers. Alright, well, now since the 608 bearings have a wider diameter hole in the middle of it, I had to 3D print these top hat shaped pieces that actually fit and center the threaded rod in the middle of those bearings. So I had to take a tap, and actually an M5 tap, and tap the inside of this, that way they just thread straight on. So the left side is installed. Now let's install the right side. It might be important to actually get these both threaded on at the right height. That way everything in the box will remain squared, but that's really only is going to be important if the bearing is actually resting on top of the brim part of that top hat shape. The only important part of this is actually using the small diameter on the outside small diameter, the top part of the top hat shape, to center itself inside the bearing. Now I'm just pushing that in until the smooth rod bottoms out on the top, just like the motor end side. Now it's colliding with the motor, so I had to move the X carriage down just a little bit. And finally we'll tighten down these retaining nuts. Now I didn't install any washers or any lock washers on these. I don't think that I need them just yet, but I can always go back and install them again later. If you want to go ahead and install them, then of course just put them on there as you're feeding that all thread rod all the way through. But this is the end of the Z-axis assembly. I hope you've been enjoying these videos so far. I'm trying to get them out on a regular basis. My time hasn't quite been available, but I'll try to get the next video out as soon as possible. I believe I'll be making the box that this goes in next. Okay? I'll see you in the next video. Thank you.